Welcome everybody. This is our 5th webinar in the ORD survey series. We've got plenty more to do, but I'll start with a just quick introduction. Kevin Laverdier, I am the lead operations surveyor for Geometronics. I've been working with ORD for 2 years now. We've been working to get the standards together and to get the workspace set up. It does take a while to get your mind used to it, but once you do, I think you'll all find that it's a very useful tool. There's a lot of good stuff in there. So today, we're going to work on some geometry basics and alignment tools. So everything highlighted there with a red arrow is stuff that we've covered before. Jonathan covered quite a bit, and then last week I did the survey ribbon and the confidence point tool. And then today you can see our main 3 topics are with the green arrow. I have a hand up from Mr. Brown. Do you have a question?
Yes, I've actually discovered I've been using Connect lately. And on our survey ribbon, the levels flyout is nowhere to be found. And I end up having to go to TopoDot or somewhere else to get that to turn on and off layers as needed.
You mean the actual levels like toolbox or dialog?
Yeah.
Yeah, now that is something that you can pin to the side of your ORD or Connect.
Oh, I did not know we could pin that. Excellent.
So this guy here, so I'll unpin it for a second so you can see. And I'll close that. So this is probably what you're talking about. You're like, boy, I don't have anything here. If you go to one of the Bentley menus and you go to your home tab, then you'll get your primary tools here.
But if you're if you change to the ORD Survey workspace,
correct,
it's not in there.
Correct.
And you have to go back to Bentley tools directly to get to it.
Right. Just like if I were to want my reference tools. So I've got my references dialog, same thing, you know, and so that's where personal preference, you know, do I want to dock it down at the bottom? I choose to dock mine to the right side. And then I can hit the little pin on it, and then it will collapse when I don't want it and expand when I hover over it.
Okay. I will make those changes. Thank you.
Right. So you're talking about in this zone. Right. The only way that you could really do it would be to use the level selector right here. Yes.
Doesn't work the way I wanted to.
Now, and I guess this is kind of a little bit of follow-up to our last session. But yes, use the ribbon tools to select where you want to draw. Don't try to drill in and get levels. Don't try to drill in and get your templates. It just becomes way too cumbersome. You know, find the thing that you want to draw and pick it off of the ribbon interface. Okay, so that's a good little recap of kind of what we were doing last time, which does remind me, I do have the video recording of that, and I'm working to get all of the bookmarks time-stamped in there, and then that will be posted up to the YouTube site in a while, hopefully in the next couple of days. So that'll be ready for you to go back and look at. So today, we just wanted to go over a couple of simple things on alignments, geometries. And where I'm going to start is with some of our ORD geometry tools. And, you know, this should just be basics. It was all stuff that we've covered in class, in the ORD tools class, ORD survey tools class. And so we'll kind of do a little review. You know, remember with InRoads SS2, we worked with the data from InRoads, we were working with just graphics on the screen. They were just a display of the design or civil data, which existed in that ALG file. But the change with ORD is the graphics contain the design data, the civil data, and there is no ALG file anymore. So we have these things called civil elements. Well, what are civil elements? How are they different? You know, civil elements are an ORD element, and they contain extra information. They contain that design or civil data, and they can contain rules and properties so that they will update when other objects or elements are changed or updated. What are these rules? Sometimes it's called design intent. And basically, a lot of these things are set up when we use the snaps or we use key-ins to key in a bearing or a distance. The element itself will remember that information and try to adhere to that rule that you just gave it. And the choice of your tool from ORD will determine what type of element is created. You still have the ability to create simple graphics, or what we would call dumb graphics. And it's all based on your choice of tools. And remember, civil elements are still graphics. They just have more of what we would call intelligence now, because they can contain this extra information that helps them link together and helps them be used in other phases of work, either work within our discipline or work within the other disciplines once we give a copy of our work to the project. So we'll do a little demo. I've got a drawing here that I started in ORD. And remember, when you do geometry, you want it to be a 2D drawing. So we have our 2D drawing here. I've got some points in it, and I've got some just general lines. But what I wanted to show at first was, what does it mean civil element or dumb graphic? Well, the first thing I'm going to do is I'll place, notice I'm on the drawing tab, which is MicroStation commands. I can snap in here and notice I have AccuDraw. This is MicroStation AccuDraw. And so if I key in 500 feet and I data point, it draws a line for me at 500 feet. If I go back and hover over that line, it just says line and tells me what level it's on. Now notice I still get a very robust pop-up menu here. I can get to properties. I can do other stuff with it. And that's because ORD has the ability to use simple graphics and either turn them into a civil object or just use them for their graphical properties without linking them to any sort of civil data. Now I'm going to go to the geometry tab and I'm going to select the line command. And notice I can draw on the same level with the same properties. It says enter start point. Now, if I enter 500 feet and hit a tab, notice on my pop-up display there, it says distance 500 feet and there's a lock. So that is locked. A data point, I've created a new object, but this time, this is a civil object. Notice it's given it a line name, RW existing 2. There's no profile. I can select it, and I have this extra stuff. This is the civil data that's contained inside of the civil element. I can manipulate the length. I can manipulate the bearing. I can use handles to rotate, trim, move parallel, or just move. On the simple element, the graphical element, I don't have any of those. Also notice we get that extended, but there's a couple of other things now. There's rules, and I can do stuff with those rules. I can lock them, I can remove them, I can unlock them. And on screen, those two objects look exactly the same. They're just graphical lines. But that's where we have to understand when we want to make a geometry and alignment, we need those to be civil elements. We need those to have that additional data in them. And you can still use graphical elements and at some point in the future turn them into civil elements, but there's additional tools if you use the civil elements. If you use the civil tools to create your elements from, then you could take advantage of the features that ORD has built into it. So the other thing that we need to introduce are feature definitions. Can't grab a hold of that. Oh, I need to be right there. Now I can grab a hold of it. I'll pull that off just so it's a little easier to see right now. But this is the feature definition toolbar. And that's our feature definition lock. Use active feature definition. So feature definitions are going to be important to us. We have feature definitions for alignments. And we have feature definitions for linear things, such as right-of-way proposed, right-of-way existing, right-of-way easements, right-of-way access control. Now, if I choose an active feature definition and I draw a new civil line, even though my active properties were set to serve work draft with bi-level symbology, notice that civil element has taken on the properties that are defined by the feature definition. The feature definition says you're going to be a P right-of-way fee access line. Well, what if that was a mistake? I want that to be a right-of-way existing line. Now, it's on survey boundary right-of-way. It's an existing right-of-way line. So that's part of that intelligence or those extra abilities that civil objects allow us to use. So let's just review a couple of the tools here. We can do line between points, line to an element, different options thereof. We can do a line between arcs. We can do a line from an element. We can do chamfer between points. We have arcs. We can do circles. Basically the same sort of options are available for arcs. We can do them between elements, from elements. And then we have geometry points. Now this is the replacement for what we used to call Kogo points. And we're already familiar with one type of a point, and that's a survey point. Notice here in this drawing, I have some monuments that I've already brought in from data. And what you're seeing here is this is a civil element. It has all of this additional information built into it. Names, field codes, descriptions. That's because it is a survey point. If we were to place a geometry point, this just becomes a horizontal point.
Hey Kev, this is Chris.
Yeah.
Sierra had a question in the chat about feature definitions.
Okay. Let me pull up the chat. I was not watching that. Thank you.
Yeah, I figured get to that before you move on to the next thing.
So, good question. Should we be using feature definitions instead of level selection? And I will say yes, but with a caveat. When you are drafting civil elements or civil objects. So in this case, where we were drafting what we want to be some right-of-way lines, or especially in the case where you want it to be a center line, that is obviously going to be a civil element. So when you create that, you need to create it with a feature definition. And that way it'll have the proper properties. But if you are creating a deed shape, then you would probably not put a feature definition on that, because that is, as of this point, not something that we need to have as a civil element. And that's kind of a not complete answer, because obviously we're still seeing everything that this program can do. And there might be a point in the future where we do want all deed shapes and all parcels to be civil elements so that we can use additional tools with them. But we haven't completely made that decision yet. So points are another civil element. Survey points or just regular geometry points. I'll complete this first section by saying there's good information in the ORD survey manual that you got for class. Always go back to that and review that if you want to understand some of these tools. There are additional tools in here, offsets and tapers, that will be used when we talk about creating right-of-way based off of the alignment that you've already created, and some uses of those, but we're not going to get to that in today's topic. So alignment creation. The first thing I wanted to bring up is that tools in ORD are really geared towards a design mindset and not from a survey mindset. So you notice a lot of those, were an arc from a line or an arc with this or that. And keep that in mind when you're using some of these tools. It's made from a design standpoint, not from a recovery standpoint. And so I know a few of you out there have kind of been tripped up by this as you're trying to work through this new process. And we've had some good lessons learned. And so that's part of the idea of these webinars, is we can share those so that we don't all have to learn them in as painful of a process. And that leads into this next point. some of the tools in ORD will, modify or build the geometry based on the end of the tangent rather than the PI of two tangents. So that is something to be mindful of as you try to go from record data into fitting found monuments, or basically retracement mode. And the logic I put behind that is it's more from a design standpoint. When a designer looks at alignment, they're building onto the end of the tangent to put a curve by a design manual that will fit the situation. And we're looking at it differently. We're trying to evaluate existing evidence and recreate an alignment that was already out there. So we approach it a little differently. There's two kind of main ways that I think about doing these alignments. And I think everybody has a little different approach based on what they're encountering or what their experience has been with past projects. But my personal preference is I always like to make the record geometry, the geometry as it comes off the map, in some open space. And then I reference it into where my monuments are just to see what's going to fit, what's not going to fit before I start trying to figure out how to modify that record geometry. The other main method is you can build the geometry in the coordinate correct space right along with the found monuments and start your retracement process. And I think that just comes with experience. How well are the monuments in your area fitting with what the records on the map are? How old is the map you're using? I think a lot of us can have stories of when they fit great, and a lot of us have stories where they didn't fit at all. And so you have to have a variety of methods, and you have to use your professional judgment to pick the one that fits. I'll just point out the little screen capture I have here as an image to dress the page up. Notice all the orange text. Those are all manipulators. That means in ORD, you can change any of those objects. And then also notice the three little bluish dots here. That is an indication that ORD is remembering the rule that basically makes that PI, that our incoming tangent intersects and our outgoing tangent is based off of where they intersect. So basically those two tangents are connected in the background in that civil data. So let's go start this process. Let's see how it looks. So to start building an alignment, I'm going to go pick a feature style that is alignment. And let's say I pick Survey Main. That's my chosen feature style. And remember, you want your persist snaps and rule on. That way it remembers how these objects relate together. And for this exercise, I'm just going to do it in open space down here. And I have a little cheat sheet off to my side that tells me what the bearings and distances were off of. Actually, I will show you. So this data comes to us from Region 4. Here's the right-of-way map, May of 1960. Notice Mr. Fowler has been in to add some stuff to it. And this is Deep Creek. And so there's our incoming tangent. On the next clip I have here, here's our curve data and our outgoing tangent. So I've set my feature definition. I'm going to choose a line, and it says enter my start point. So remember, with the blue arrows on my pop-up box here, I can cycle between direction and distance. So the direction I want is south, 77 degrees, 01 minutes, 45 seconds east. And notice when I move my cursor, it didn't hold, it didn't lock in. That's because I didn't hit a tab. I didn't move out of the entry field to actually lock that direction. So I got to do it again. South, 77 degrees, 01 minutes, 45 seconds, east. Now, if I hit a tab, notice my lock is on there. My screen still doesn't display that angle until I move the cursor. And now I am locked into that angle. I'm going to make this line 2,895.14 feet. Then I hit a tab again so it locks in. Now notice it doesn't matter what I do with my cursor because both of those options are locked. So I'll data point and I've ended the line. So I'm in a new line command. And remember, we want to use snaps so that it creates those rules. So I'm going to snap to the end of my first line. And then I'm going to enter the second direction, which is north, 89 degrees, 18 minutes, 30 seconds east with a tab. So I'm locked into that direction now. And the distance isn't quite as critical because we're just going off into our second tangent. So I'll just enter 1,150 feet. That'll put it out far enough. So now that tells me I have survey 1 or survey main 1 and survey main 2. At this point, I have two civil objects that are related to each other, but they're not connected. They're not an alignment. They're not a complete alignment yet. They're an alignment of in themselves. Each one of these is its own alignment. If I select this one, select the report tool, you'll notice that it starts at station 0 and it goes to a station 11 plus 50. But it does tell me it starts on survey main 1. So the next thing we want to do is insert our arc. Well, let's go back to the PowerPoint slides real quick. So here's the basic steps. Create your tangents first. We're going to add our curve sets. So let's go add our curve set. So we're going to say arc between elements. And we have a spiral arc spiral per our records. So my recommendation is to fill out the boxes before you pick the elements. That way you know all of the information is correct. So I don't know what our radius is, because if I pull up our drawing here, all we have is it's a 1 degree, 30-minute curve. Well, I can handle that. 1 degree, 30-minute, you put a D after that. Now, this doesn't work in every curve entry box, but it works in these main couple. If you put a D in there and I hit a tab.
Kevin, I think the D goes before.
Oh, is that what it? Thank you. Yes, the D goes before. Oh man. That's what I got. That's what I got help for. I need it. So, and notice I used a 1.5 because a 30 minutes is half a degree. So you can either use the minutes, the degrees, minutes, seconds, or you can use its conversion to decimal. So we have our radius, and we're going to have two spirals, equal spirals, 375 feet on each end. And then we're going to say trim extend, and we want both of them. So we follow the on-screen prompts, locate the first element, locate the second element, and now it's going to let me put it. It can put it either place. So I have to pick the right place. It's going to make you accept that selection again of both. And now we've created the curve set. Notice if I hover over it, it's calling it Survey Main 3. So we had Survey Main 1 on this side, Survey Main 6 on that side. Wait a minute, why are they saying 6 and 7 now? And I'm going to zoom in a little bit closer so you can see this. Notice how this manipulator text is now white. I can't edit it. That is the intelligence of ORD coming in. When we created this tangent, it went all the way down to the PI. So I can still move the PI point. I can still rotate this line if I need to fit something, but I can't manipulate. Notice how the resultant tangent is what's purple. If I want to modify that line, I have to come back into the original line, and that's Survey Main 1. That's what ORD remembers as the original line. So we've got our curve sets. For sake of time, I'm not going to get into fitting through the curve, but the tip here is leave the alignment in separate pieces like this while you are fitting your recovered monuments. I can modify any piece of this alignment, and because those two tangents are what were used to make the curve set in the middle, when I modify the curve set, those resultant tangents modify along with it. That intelligence, that rule is bringing it along. So you can modify this all you want and get it to fit the evidence that you found. And then once you've got everything fitted and you're happy with what you're recovering or resolved, then you would complex the alignment together and define your starting station or any station equations. So let's do that real quick. So I'm going to say complex by element. I'm going to use an automatic method, and I want my gap to be really, really small here. We don't want gaps in our alignments. If I put this up to 10 feet and there was a missing segment of alignment that was 9 feet long, ORD would say, fine, you told me you could do that. So we want that maximum gap to be very small. You want to select your alignment closest to the starting point, and you want to pay attention to what direction that purple arrow on screen is showing. Notice if I pick on this end or this side of the center point, the purple arrow is going to point the wrong direction and my alignment's not going to connect correctly. So I make a data point. It's going to highlight the rest of everything that it found that's within that maximum gap. And it's going to ask me if I want to accept that. I say accept. And now I have a complex alignment if we pull the report for that alignment, now we have a linear, a clothoid, a circular, a clothoid, and a linear. We have all the components of our alignment. So the key point to remember there is, use your feature definitions while you're creating, and use your snaps. And when I say key ins, that's where we keyed in the distances and bearings. And those key ins and those snaps will create the rules. So, a couple of last tips. The transform tool can be used to move or create copies of an alignment. This is the transform tool. Notice it comes with a warning. And there's some very powerful settings with it. So this is another topic. We could do probably a whole webinar just on using the transform tool. There was a transform tool in InRoads, and that's how we could adjust from an old project to a new project. But this is one of those situations where if I were to use a simple microstation command and try to copy this civil element, I get the complex chain, but notice I don't get the civil element. So if you need a reference copy, or if you need to rotate it as a whole and fit it to something, you can't use the microstation commands. Using the microstation command strips the civil data. Now, the other tip, right on the heels of that, be careful with the microstation commands and your civil elements. Some of these commands are made to work with civil elements and are the only way to work with civil elements sometimes. But some of them can also corrupt the civil data. And usually when the civil data is corrupted, it is an unrecoverable event, meaning we have to go get a backup copy of your DGN before that corruption happened.
Hey, Kevin, is there a way to save that alignment so that maybe you could save it before making some modifications that you wanted to keep as an external file?
Yes. You would have to ask me that. You can export the geometry, and you could export it as a land XML version, and then go through those steps. And that will save the geometry as an XML. And then if you wanted to bring it back in, you could import it from that same XML file. The other option would be to use the transform tool. And then you can create a copy. And when it creates that copy, you don't even have to move it, because when it creates the copy, it'll increment the name of it. So now that I use the transform tool, I have a main 4 and I have a main 5. If I go to main 5, I can change the display style to minor. So I have my main now, and I have my minor. Two exact duplicates of the alignment. Let's just work with the main. So where am I for time? Okay, we're coming up on the end. Alignment display. So annotations are used in ORD for alignment display and labels. The nice thing is the annotations are based on the feature definition that you've given your alignment. So by changing the feature definition, you've already set yourself up for displaying the alignment when it comes time to build your map. So when I do the demo, I'll demonstrate kind of some of the differences in these feature definitions that we already have set up for right-of-way and survey. They're both built on the same idea. They both work in much the same way. Now, one of the things you need to know about these annotations is some of the items are extra and will need to be removed. And in this example here, this is kind of why I chose this picture. You'll notice we have two sets of curve data for this alignment. One of the sets is the complex curve or the spiral curve spiral, which we want, and one of them is just the simple curve. Well, we do not want the simple curve label, so that would be something that needs to be removed. You ask, why are there items that need to be removed? Well, as much as we tried, Bentley has a certain way that it wants to make these labels. And because we want the spirals labeled, we have to get the central curve labeled the same way. If we didn't want the spirals labeled, then we could go with just the curve set. But because of the way the tools were written, it's what we're left with. And the approach we've taken is it's easier to remove information than it is to create information that was not included. So it's easier to manipulate and remove this extra curve set label, the extra PI label that's going to come, than it would be to try and create the stuff if we didn't include it with the annotation definition. Now, be warned, the annotations do update when the alignment is modified. That can be a good thing or that can be a bad thing. So it's best to complete any edits or modifications to your alignment annotation as the last step in your process. If you spend a bunch of time making the text pretty and getting everything the way you want it, but then you decide we need to extend the alignment, or we didn't, we found some new evidence, we need to fit the curve a little differently, then all of that work's going to be lost as soon as you modify the alignment. So it's super easy to add the annotation. Here's my annotate element tool. It's telling me to locate my elements, so I locate my alignment and I reset. It's now drawn all of my alignment annotation for my serve main. Notice it's put the name in there, serve main 4, and I'm like, oh, well, I don't want it to be named serve main 4. I can change the feature name on the fly, and let's just call it 8B because it came from the 8B map. So that's going to be my designator for now. Well, the annotation didn't update. Easy enough. I say remove annotation. I say add annotation. and now it's labeled it all as 8B. Here you'll notice where the PI gets labeled twice, once for the PI that we want, which can be, you can get a clue to that because when you hover right here, you see the ends or the phantoms of the original tangents. You can see that the PI that it's labeled right here is the PI for the simple curve in the middle. So that means that information, and that line are all extra. That's the PI station for the simple curve, whereas that's the PI station that's relative to our map. Now, one thing I didn't notice here is I forgot to add the starting station. So my starting station says locate the element. Starting distance. And the starting station is going to be 180. Notice when I made that modification to the alignment, the annotation updated. That's because I made an actual modification to the alignment and not just to the name of the alignment. And remember, I had moved that PI and now it came right back. So this time, I'm just going to delete the extra, but if I do anything again, it'll come back. So 208, 95, 14, 202, 49, 88. Let's go back and look at our image. 202, 49, 89. Darn it, it didn't hit by 100th. I think we'll be able to live with that though. So we said we had some different annotation or feature definitions. What do they do? So what if we just change to survey main no name? With no name, it takes out all of those names that it was putting in on the stations. Notice it put the PI back again. So like I said, don't do anything to modify it until you're done with your alignment completely. So we have survey main no name, survey minor, and I'm going to go to survey ramp for this next one. So the survey alignments, all of the text, all of the leaders, the labels are kept the same color as the alignment. And this is so that as we build our retracement surveys, when we have multiple alignments that seem to always want to float on top of each other, that we can easily distinguish them when we're working with them based on color. And usually when we do our filing maps are in black and white anyway, so it doesn't matter what color's on screen. Might take some getting used to. I know we haven't always done this in the past, but it was something that we wanted to put in and see if it helped make life a little bit easier when you're working on these. The right-of-way alignments, we have right-of-way centerline prime, right-of-way centerline prime no name, centerline railroad, and then centerline secondary. So let's start with centerline prime. You'll notice the center line's a little different. It has the coral snake effect. And that's something that you'll see in some of the other alignment styles, but not in survey. And that's just to make it real easy to spot where an arc curve is or where a spiral curve is. But it follows the same basic standards that the survey one does. This one, of course, has the name, has everything set to our general right-of-way standards. So everything is on a right-of-way centerline prime text, centerline prime text or a prime tick. Won't demonstrate the no name, same thing as the survey no name. The railroad center line, same thing, follows the standards that we've had before. And of course, the secondary center line. It's not as heavy of a weight for all the objects as the primary is. So you can see real quick how even if I had chosen centerline scratch to draw my original alignment with and work with, after I'm done, I can change it to any feature definition I want, and it will display with the correct symbology for standards. So those are the basics of the alignments that I wanted to show. It's probably not all new information, but hopefully you got something out of it. We're at the end. I'll come up with the questions, or basically my little review. We have civil elements, we have dumb graphics, dumb objects, dumb graphics. Just be aware of what they are and how they help you and hurt you. When you use your alignment creation, when you do your alignment creation, use feature definitions, use the snaps and the key ends. And then for alignment display, the different feature definitions help you get your graphics to standards, and wait to the end to edit any of those. Let's see. JP has a question. Is there an edit horizontal element tool similar to InRoads? There is not. And that is because if I want to edit this horizontal to say a different bearing, I edit the manipulator itself. So there really is no need for an edit horizontal tool. If I want it to be a different length, I can move it manually, or I can move it by using the manipulator. Now notice what I just did there is I made it 2,500 feet. So that lengthened it out. So this tangent remembered that I picked a start point and then went this direction, my distance. And then when I wrote this tangent, it started from the end, went a direction and a distance. So when I told it 2,500 feet again, it remembered the first rule, which said start here. And then it moved out 2,500 feet, and then it remembered that the second tangent was attached to that. So this whole thing, if I undo it, you see that whole thing, it didn't change the angle. The angle was retained. And that's because I drew the second tangent with the proper bearing.
So Kevin, when you changed the back tangent bearing, did that change your curve, or did that change the ahead tangent?
'89, 1830. it changed my curve. Total delta by record was 1339.45. Yeah, that should be an 0145. So yeah, it added 20 seconds in here.
Some of those components of your alignment, can you lock so when you make a change back or ahead, it doesn't modify something that you wanted to hold?
I don't know. Like if you wanted,
fair enough.
If you wanted to lock a tangent distance, let's say, it all depends on the order that it was drafted in. Just like, because remember, well, and see, this is even still remembering where this used to be. It remembers it before I did that move of the end. So because it remembered I wanted to go from the start point, a certain bearing, a certain distance, that's what it does. Then it does the next tangent. And because the two curves were built off of the tangent, or not two curves, the curve set was built off of the tangent, then the curve is modified to fit wherever the tangents are now. Does that make sense?
Yep.
So we are at 3:30. Do I have any other questions? All right, I thank you for your time. And I will leave you with one question that if you want to send us some email input, that's fine. You don't have to answer it now, but are you still good with one of these a week? Or do you want to take a week off, have a down week so you can think and regroup? And are there any pressing topics that you would like to see presented before something else? That's kind of the feedback that I'm going to look from you guys as users. If we get too overloaded, then we can take a break. But if once a week is still good, then John and I will try to keep it going once a week.
Hey, Kevin, now that you mentioned that, I may put together a little survey and send it out to everybody, and then they can just, chime in that way. That way we can get good responses. So
Thanks, John.
Yeah.